Hello, my name is Robert Smith, and I'm with New River Community College. And today we are looking at the Nernst equation. This is part one of a two-part series involving the Nernst equation. And the Nernst equation is simply our cell potential is equal to the cell potential at standard state minus RT. R is the gas constant, T is temperature, over NF, where N is the moles are the moles of electrons involved in the reaction, and F is the Faraday's constant, and times the natural log of Q, which we know to be the out of equilibrium constant. So this can occur in you can use this formula for many different reasons to calculate many different things. But let's just use this specifically for this problem, and then I have another problem in another video. So we're going to predict whether the following reaction is spontaneous at 298. Okay, so 298 K is standard temperature, so as long as we have it at standard temperature, then we can make a couple of simplifications to the Nernst equation, first and foremost. At 298, RT and N, this term, RT and F rather, RT and F are constant. So it would be, and that constant is 0.0257 volts over however many moles of electrons times the natural log of Q. So that's our simplified Nernst equation for this purpose. So once we have that simplification, we can go ahead and look at our reaction and break it up into two half reactions. The anode, which would be our cobalt, going to cobalt 2 plus 2 electrons, and our cathode, which would be iron 2 plus 2 electrons, going to iron solid. So because the moles of electrons are equal for both reactions, we can just pull it directly from the half reactions to put in for our N. If they were different, like if one had 3 moles of electrons and the other 2, then you would want to multiply them by factors to get them both to 6. And 6 would be the total moles of electrons. But now we know that N is equal to 2 because we have 2 moles of electrons in either equation. And the next thing we'll need to do is find our E cell at standard state. So our standard potential, reduction potential. And that's going to be the, remember that is the cathode minus the anode. And if you look that up, you would do, you would find that it's negative 0.44 volts minus negative 0.28 volts. So that's like saying plus 0.28 volts. So this would be negative 0.16 volts. And so now we're going to look at this and plug in those values. The only other term that we need to think about here is Q. And Q is going to equal, it's going to equal 0.51 over 0.86. And that's just based on how this is written. So it would be products, which you don't include the solids, but so the product would be cobalt 2 plus, which is 0.51 molar, over reactants, which in this case would be Fe2 plus, which is 0.86 molar. So now we just plug in everything and perform the calculation. So this would be negative 0.16 volts minus 0.0257 volts over 2 for the N times the natural log of 0.51 over 0.86. And when you do that calculation out, you get approximately negative 0.15 volts. So this out of equilibrium caused the potential to increase by 0.01 volts. Now, we're asked whether it would proceed spontaneously. And the easiest way of doing that is to relate it back to Gibbs free energy. If you recall, in terms of Gibbs free energy, if Gibbs free energy, the change in Gibbs free energy is negative, then the reaction will occur spontaneously. And if it's positive, it will not be spontaneous. So let's have a look. So delta G is equal to negative NFE. You could also say delta G naught is equal to that, E naught, but we're not worried about that because this is not in standard state. So we're just looking at delta G in general. And when you do that, you find that as long as E is negative, as long as the cell potential is negative, then our change in Gibbs free energy will be positive. So therefore, this is non-spontaneous. You can look at this equation and determine that there are concentrations of cobalt 2 plus and iron 2 plus that could result in a much larger cell potential, more positive cell potential. If that cell potential ever gets to a something that's very positive and it's higher than 0.16 volts, then our change in Gibbs free energy will be positive, will be negative rather, and that will mean it's spontaneous. So that would occur primarily if the concentration of iron 2 plus was much, much greater than the concentration of cobalt 2 plus. So if this denominator gets very large while this gets very small, then you would have a much more spontaneous reaction because this whole term would turn positive and become larger, and eventually it would overtake the 0.16 volts of the standard state cell potential.